Okay, so today we're going to start 4.1. Wait, let me actually do this. Okay, so today we're going to start 4.1, which is polynomial functions and models. Couple key things I want to point out before we start this unit is standard form. Okay, when we have a function in standard form, the easiest way to differentiate between standard and factored form is that in standard form, everything is multiplied out. Everything is multiplied out. There is no parentheses, and the last number is your constant, which is also your y-intercept. In factor form is set up for you to easily find your x-intercepts. The first number is your leading coefficient, and each parentheses represents a different factor. Each factor you would set equal to 0 in order to find your x-intercepts. The third key vocab is degree. Your degree is your highest exponent, and the leading coefficient is the number paired with that highest exponent or with the degree. So in behavior, there's essentially 4 different types of in behaviors. The first thing you want to look at is what is your degree. If the degree is an even number, so if the highest exponent is an even number, such as 2, 4, 6, 8, 10, that means that the behaviors will be the same on both sides. Okay, so if it is a even with a positive leading coefficient, both sides will go up, or they will both rise. So they're both going to go up. But if it's an even degree with a negative, then both sides will fall. For an odd degree, such as a linear, a cubic, a fifth degree, odd opposite. What the function does on the ends will be the opposite. Okay, so if the function is an odd, that means that one side will decrease while the other side will increase. Now, what I like to think of when I'm trying to determine the in behavior, the first thing I do is I determine if it's a positive or a negative. Because if it's a positive, it tells me what the graph is going to do on the right. All positive functions, all positive polynomials, or functions that have a positive leading coefficient will increase or rise on the right side. And if it's odd, the left is going to do the opposite. But if it's even, the left will do the same. All negative functions, or functions with a negative coefficient, will fall on the right. But if it's odd on the left, it's going to do the opposite. But if it's even on the left, it's going to do the same. Okay, so now that we've kind of went through some of the basics, let's go ahead and jump in. So feel free to pause the video at any time, as always, to take notes or copy down key things. So I'm just going to answer a few questions about this function. First of all, what is my degree? All right, so my highest exponent is 4. And my leading coefficient, or the number paired with that, is a 5. The y-intercept, if you were to substitute a 0 in at every place that you see an x, all of these numbers would cancel out. So the constant is 1, but that is also your y-intercept. Okay, so if you're trying to find your y-intercept, you don't necessarily need to substitute in a 0 for x. Look for that number that is a constant, that one number that doesn't have a variable, and that will always be your y-intercept. All right, so now let's talk about our in behavior. Now, because this is a positive 5, that 5 is positive, I know that it's going to increase on the right. But because the degree is even, it's also going to do the same thing on the left. So that means that as x approaches negative infinity, f of x will approach positive infinity. And as x approaches positive infinity, f of x will also approach positive infinity. Okay, you can also, whenever it's an even degree, you don't have to split it into the left and right. Because it has the same behavior, you could also say as x approaches positive and negative infinity, f of x approaches positive infinity. So now let's look at the second function here. My degree is 5. My leading coefficient is negative 2. The constant is negative 4, which also means that my y-intercept is at 0, negative 4. When I draw a sketch so I can visualize what's happening at the end, because I have a negative leading coefficient, this number here is negative, that means it's going to decrease on the right. But because my degree is odd, it does the opposite on the left. So my end behaviors on the left, as x approaches negative infinity, f of x is approaching positive infinity. And on the right, as x is getting larger or approaches positive infinity, f of x is decreasing or approaching negative infinity. So let's discuss how do you find your zeros. So this first function is in factored form, whereas the second function is in standard form. So if it's in factored form, it's quite simple to find our x-intercepts or our zeros because we're simply going to set the factors equal to 0. So this has 3 different factors. So when I set this first one equal to 0, I have x equals 0. When I set the second one equal to 0, I have x plus 4 equals 0. And then when I set the third one equal to 0, I have x minus 1 equals 0. And when I solve all 3, my first x-intercept is at 0, 0. My second x-intercept will be at negative 4, 0. And my third x-intercept is at 1, 0. We'll talk about what these numbers or the exponents inside or outside of the factor mean in a little later of a video. Okay, so now let's look at the second one. So this is in standard form. So the first thing we're going to do, there's a lot of different methods, but the first thing we're going to do is look for our GCF because we have to solve it. So I'm looking here and I'm noticing I can factor out an x cubed. And when I factor out x cubed, I have x squared plus 3x minus 10. This is a quadratic, and you can either factor that or use your quadratic formula. Now because it's factorable, I'm just going to go ahead and factor it down. So I would need 2 numbers that multiply to be negative 10, but add to a positive 3. Now that it is factored, I can set all 3 equal to 0. So my first is at 0, 0. My second one is at negative 5, 0. And my third is at 2, 0.